factor. So this list is all the factors. And yesterday when I had you look between 36 and 54, and we found 18 was the biggest one, that would be the greatest common factor. And so that's what we're doing as we go through this process, is we will be looking for the greatest common factor. So in the multiplication problem, so here's our problem right here. 2x times the quantity x plus 4, and that equals, when we distribute, 2x squared plus 8x. We did that yesterday. 2x and x plus 4 are the factors. These are considered the factors. And 2x plus 8 is the product. Sorry, 2x squared plus 8x is the product. So that's how we talk about those. We've got factors, the pieces that make up the product, or the biggest part. So if we reverse the problem, when we do it backwards and we take our answer and break it into two pieces, we say that we have factored 2x squared plus 8x into, 2x and x plus 4. So when we factor something, we take a big expression, a big number, a big problem, and we break it into smaller pieces. So when we look at this first couple of things, we're going to look at the products, and then factors, and then we're going to identify the products. So it says name the factors and the products in each problem. The factors are the two small pieces generally on the left. So the factors are 3x and x plus 9. That means the product, or when I multiply them, I get 3x squared plus 27x. So all we're doing right now is identifying the different pieces of the problem. So for number 2, I have negative 10x and x minus 6. So it's negative 10x squared and x minus 6. With our product being negative 10x cubed plus 60x squared. And for number 3, those are my factors. They're generally separated by parentheses, so that I get 4xy squared and 3x plus 8y. And when I multiply those, their product is 12x squared y squared plus 32xy cubed. So all we're doing is identifying the different pieces, so that when I use these words, the factors, the product, that it's not extra garbage. So this is reverse of what we did yesterday and the day before. Mostly the reverse of what we did on Monday. This is reverse multiplying. We're going to break them down into the factors. So we are looking for the greatest common factor. The greatest common factor, we'll abbreviate that as GCF. The greatest common factor is going to be the largest integer and the highest degree of each variable that will divide evenly into each term. So it has to divide, the coefficients have to divide, and then it has to be the highest number of x's that I can get out of both things. So there's like a 3-step process. We find the GCF of the coefficients. We talked about what a coefficient was yesterday. Of all terms. So we want the largest number that goes into them all. This is where you're going to use your blue card. So if we look at your blue card and I ask for the GCF of 42 and 50. Look at 42 and 50 and tell me what the greatest common factor is of 42 and 50. What's the biggest number that goes into both of them? What is it? 2. 2 is the biggest number that goes into both 42 and 50. Shh. So then we find the GCF, greatest common factor, of the variables. Shh. In this case, I want the smallest exponent that is in everything. So if I have an x squared and an x, what's the smallest exponent? If I have x squared and x, the smallest one is just x. So that's what we're looking at, okay? And then once we're done, we rewrite our answer as a single term. So we pull out the coefficient and then the variable, and that becomes our single term, which is a product of 1 and 2. So when we look at number 4, I'm looking for the GCF. What's the smallest thing? So when we're looking at variables, remember I want the smallest exponent that's in everything. So what's the smallest x? X. So the smallest one, so the GCF is x, and what's the smallest y? Y2. That's it. So it's the smallest exponent of each variable. So if I break it down, this is x times y, and this is 1, 2, 3, 4, 5, y. You can see that I have at least one x in both. Excuse me. And 2 y's in both. So that's where that comes from. Now we have one where I have coefficients and variables that I need to deal with. So looking at your blue card, we can do this 2 ways. We can use the blue card, or we can just go ahead and look at it and say, I know that the factors of 8 are 2 and 4, and the factors of 18 are 2 and 9. So, and then I can break 4 down into 2 times 2, and I can break 9 down into 3 times 3. Anybody remember what this is called? This has a name. What's it called when I break them down like that? It's called a factor tree. So you did that in, I don't know, 6th and 7th grade. So what's the number they have in common? 2. So I'm going to use this 2 and this 2. That's my GCF for the coefficients. Now, I have 1, 2, 3, 4, 5, 1, 2, and I have 1, 2, 3, 4, 1, 2, 3, 4, 5. What do I have as far as x's? 2 and 2, and 4 y's and 4 y's. So then it's x squared, y 4. Last one. I don't know why that term is so small. Looking at your paper, what's the GCF? The greatest common factor between 18 and 27? 9. So my GCF is 9. And then, do I have the same variable in both terms? No. Nor do I have in either term, right? I don't have x's in both and I don't have y's in both. So my greatest common factor is just 9. That's okay too. This Miss Adams. He's not here today. Or at least not yet. He might be late, but he's not here yet. Bye-bye. All right. So when we factor, so what we did just now was to find the greatest common factor, and now we're going to use that to break our bigger products into smaller pieces. And it's kind of like reverse distributing. So we're just undoing the distributing. So our steps are to write the GCF in front of parentheses. Then we divide each term of the polynomial by the GCF. So that's what we did yesterday, where we were dividing each term. And then we rewrite the remaining terms. I think I spelled that right. Inside the parentheses. So we find the GCF and then we write some parentheses. And then we divide and whatever's left over goes inside the parentheses. So let's try that. When we look at number 7, from the coefficients only, from 7 and 14, what's the GCF? 7. And then I don't have the same variables, right? So that's all I can do. So we write the GCF and we put some parentheses. And then we're going to divide. Actually, let me space that down a little bit. So when I divide that each term by the GCF, what's left in the first term? 7x divided by 7 leaves me with x, 1x. Plus 14y divided by 7 leaves me with 2y. That's it. Now to check it, if I redistribute, 7 times x is 7x, and 7 times 2y is 14y. So that's how you check it to make sure that you factored it correctly and that it's as simple as it can be. So let's look at number 18. Again, either looking at your form, your blue card, or because what's the greatest common factor between 18 and 12? 6. Now, I do have the same variable in both terms. So I want the smallest one that's in both. So I need x to the third. So again, we write 6x3 outside, and we put that next to parentheses. And then when I divide by 6x3, what's 18 divided by 6? 3. And then x6 minus x to the third is x to the third. Minus 12 divided by 6 is 2. But then x3 minus x3 is 0. So then I'm done. And again, when I go back and redistribute, I should get the same answer that I started with. You spent weeks doing this last year. I'm sure it was so much fun. You will spend weeks doing it next year, and probably the year after that. Like, this is so much of what the rest of your math career looks like. And so that's why we're focusing on it, because we want you to be able to do it and be successful and not hate us. I don't want to be in your nightmares later. All right, let's look at number 9. Okay, so this might be one you want to use your card for. 17 and 34. What's the greatest common factors of 17 and 34? 17. Try, like, you're going to have access to this card, but one of the things that you can do when you get this is take the big number and divide by the little number. If it works, then you can keep going from there. Always try 2, but sometimes it can be better. So my greatest common factor is 17. What's the least number of A's? A. And the least number of B's? Just one B. So that's my greatest common factor. So then we put 17AB, some parentheses, so I have enough space here. And when I divide by 17AB all the way across, let's figure out what we're left with. So 17 divided by 17, that's 1. A2 minus A1, or divided by A1 is A. B4 minus 1 is B3. And then we do plus. 34 divided by 17 is 2. A's cancel. B2 minus B1 is B. Plus 17 over 17 is 1. A over A is 1. B over B is 1. So I'm left with plus 1. All right. Now, this one looks weird because it's got a minus sign, it's got some parentheses, and we didn't have parentheses before. But remember that what you're looking for is what's in both things. What's in both things? This is in both things, right? There isn't a single x in both things. I can't divide 3 and 4 by anything, but this, because that's a thing, it's in parentheses, that's the same thing. That's in both terms. So then that means my GCF is x plus 1. So if I write that outside, x plus 1, what's left? What's left here? 3x. Oops, that's a minus. And what's left here? 4. All right. Last kind, because we just want to make life a little harder. If there is, the leading coefficient has a negative. I want to pull that out. So when we look at the last couple, what goes in to 5 and 35? What's the greatest common factor? 5. But I'm going to say negative 5 because I want to have that with me. And then what's the least x's, the smallest x? X, and the smallest y is y. So I have negative 5xy. So when I divide by negative 5xy, all that's left in the first one is x, right? This cancels, and that becomes a 1. And when I divide this by negative 5xy, what's 35 divided by negative 5? Negative 7, and then my x and y both cancel. Look at the signs and how they changed based on what we did. Let's do it one more time. And you can practice and fix your Wheel of Theodorus. All right. What's the common factor for 2, 14, and 6? 2. So my GCF, and we're going to put negative 2 because I want to get rid of this. So, and then the least x is just 1x. So negative 2x. Okay, so negative 2x to the fourth divided by negative 2x leaves me with positive x3. 14 divided by a negative 2 is negative 7x. And two negatives, negative 6 divided by negative 2 is positive 3. And then my x's are canceled.